Okay, so why are these coordinates the way they are? Why are the coordinates here rad 3 over 2 comma 1 half? Why are the coordinates here rad 2 over 2 comma rad 2 over 2? Why are the coordinates here 1 half comma rad 3 over 2? So the simple explanation is because of special right triangles. If you don't understand special right triangles, you're going to have a hard time understanding this, so I'd recommend you watch my videos on the special right triangles. Otherwise, I'm going to proceed and assume you know it, otherwise it's just going to take too long to explain. So the first thing I'm going to do is I'm going to draw a radius from the center of the circle to this point on the circle at 45 degrees, right? So this distance is called the radius, and we know the radius here is 1, right? So I'm going to write r equals 1. And I'm going to make a right triangle out of this. I'm going to drop this height here straight down and make a right angle here, right? So since this is 45 degrees here, then I know this angle right here, theta, which I'll call theta, is 45 degrees, right? And if this is 90, then what does this angle have to be? This angle must be 45 degrees as well. So this is 45, 45, 90. That's one of the special right triangles. So if you watch my other video, you know how to go from the hypotenuse to the leg, right? To go from the hypotenuse to the leg, you divide by rad 2. So this side here is going to be 1 over rad 2, right? But you're not supposed to have a radical in the denominator, so what if we rationalize that? So we rationalize that by multiplying by rad 2 over rad 2, the top and bottom by rad 2 over by rad 2, top and bottom by rad 2. So that becomes what? Rad 2 over 2. So that is where this x value comes from. And this is an x value, right? This is an x value. This leg is an x value, right? So this side of the triangle, this leg, this x value, is rad 2 over 2. And if you understand 45, 45, 90, you know that's isosceles, so these two sides are the same. So if this side is rad 2 over 2, then this side is also rad 2 over 2, which happens to be what kind of a value? It's a y value, right? Hence, that's why the y value here is rad 2 over 2. So rad 2 over 2, rad 2 over 2, that brings us to this point right there, right? So that explains these coordinates right here because of the special right triangle, the 45, 45, 90. I'm going to erase this. If you want to copy it, pause the video, okay? So we are going to repeat this process, but of course we're going to now use the special right triangle for the 30 degree, 30, 60, 90, right? So now I'm going to draw a radius from the center to this point right here, the 30 degree angle on the unit circle, right? Again, I drop the height straight down, that's a right angle. And this is a 30 degree angle, right? So I know this angle is what? 30 degrees, right? That's what this means, 30 degrees, right? Just like 45 would be right there, right? So if this is 30 and this is 90, then what does this have to be? This has got to be 60, right? Because all angles in a triangle, all three angles in a triangle have to average 180, right? So what do we got here? We got 30, 60, 90 special right triangle, right? Well, do you see that this hypotenuse here is the same as the radius of the circle? The hypotenuse of this triangle, just like in the other triangle, is the same as the radius, which we know is 1, right? So the radius here is 1, just like in the previous triangle, right? So if you saw my other video, how would you go from the hypotenuse to the short leg? Like going around the 60 degree angle, you divide by 2. So what's 1 divided by 2 is basically 1 half, and that would be a y value, right? Vertically, y value. And what do we do to the short leg to get the long leg going around the 90 degree angle? We take this value and multiply it by rad 3. So what's rad 3 times 1 half? That would be rad 3 over 2, and that happens to be what? An x value, right? So the x value is rad 3 over 2, and the y value is 1 half. That is why we have the coordinates here, rad 3 over 2 comma 1 half, right? And so you can imagine, well, what if I just repeated this process for the 60 degree angle, right? If I erase this and I draw the triangle, right triangle there, you would see it would also be a 30, 60, 90, just with the orientation changed. So now this would be 60 here and that'd be 30 there, right? I'll do that in a second just so you can see it. But that is why these coordinates are the same, but just switched, because both of these have the same special right triangle, it's just the orientation is rotated, right? So if you want to copy this, pause the video, I'm going to erase it. So then, let's do it one more time. Let's see, maybe you can try it by yourself before you see me do it, right? So we start off the same way. Always draw the radius, right? Which is going to be the same as the hypotenuse of that triangle. You drop the height, make a right angle there, right? What's the radius? Of course it's 1. Unit circle, right? And this is 60 degrees, so what is this angle? That's 60 degrees. Which means what? This has got to be 30 degrees, right? So do you see the orientation is rotated from what it was before? So before we had 30 and 60, 90 here, but now it's 60, 30, 90, but they're both 30, 60, 90 triangles, just rotated, right? So which one, I should erase that, sorry, should erase that. So this is the hypotenuse. So to go around 60, we get to the short leg. What do? Divide by 2. So basically the x value is what? 1/2. 1 divided by 2 is 1/2, right? So to go from the short leg to the long leg, around the 90, short leg, long leg, we multiply this by rad 3. So 1/2 times rad 3 is rad 3 over 2, which is the y value, right? So the x value is 1/2, and the y value is rad 3 over 2. So the reason why we have these particular numbers here is because of special right triangles. Your 45, 45, 90 triangle and your 30, 60, 90 triangles, right? So these make all the sense in the world if you understand those special right triangles. If you don't understand those special right triangles, then at the very least you're going to have to memorize these, right? But if you can memorize these, then that's going to help you with these, and these, right? You don't have to memorize these separately, just memorize these, and then you can figure out what these are and just change the signs like we said earlier, okay?